Alright, so today we're going over U substitution rules. So in my opinion, this is one of the most used integration rules. So basically U substitution rule is, let's say we have function f of x times g of x, or even function f of x divided by g of x. That doesn't really matter. Let's say we have to find the integral of that, or the antiderivative rather. What we would do is we would give a U value to either f of x or g of x or something in there. And we would also find the du value and plug it into here in order to cancel out variables. Because what we want is, we don't want to find the antiderivative of f of x at times g of x. We want to find the antiderivative of either f of x or either g of x, basically one variable. We want to make it as easy as possible for us. And then later on, when we find the antiderivative, we plug in u for whatever's left, and then we complete the integration. So for example, let's say we had sine of x times cosine of x dx and the integral of that. So let's say u is equal to sine of x. So that means that du is going to be equal to cosine of x dx. And now what we need to do is plug in u for sine of x. So we're going to have u times cosine x. And now with this dx, we have to plug in something for dx. So what we could do is take this right here and solve for dx. So if we divide by cosine x on both sides, we're going to have that dx is equal to du over cosine of x. So now we just plug in that for dx. So we're going to have du over cosine of x. And now we could see that even though we can't plug in anything for cosine of x and get rid of it, we could actually divide by cosine of x because we have the denominator of du over here. So we could just cancel that out, and we're going to be left with integral of u du. And you could see here that now finding the antiderivative of this is going to be a lot easier. The antiderivative of u is just going to be u squared over u du, or u squared over u. And then what you would do now is just plug in sine x. So your answer would be sine squared x over 2. Alright, so let's try out these few questions. So for these questions, we're already given a u value, so we have to use the u value to integrate it. So let's write du down here. Let's first find du. So du is going to be a derivative of u, which is going to be the derivative of 2x, which is 2. So now let's start answering this. So we have integral of cosine 2x dx. So let's plug in the u values in the dx. So, oh yeah, this is 2 dx. So if we find the answer in terms of dx, we're going to have dx is equal to du over 2. It's a little bit scuffed there, but now what we need to do is rewrite the equation and plug in u and plug in dx. So we're going to have integral cosine u, and then that's multiplied by dx over 2. And we could factor out the over 1 half. So we're going to have 1 half integral cosine u du. And the reason why we could factor out the 1 half is because it's a constant. Any constant in an integral can be factored out. So now all we need to do is find the antiderivative of cosine u, which is going to be sine u. So it's going to be sine u and du. And now all we need to do is just plug in 2x for u. So if we plug in 2x, we're going to have 1 half. And we could remove the integral because we already found the antiderivative. So we're going to have sine 1 half sine 2x. And usually we would put plus c in some, if it doesn't tell you to put it in an equation, you don't have to put plus c, you just find the antiderivative. But for this scenario, we could put plus c. Alright, so let's take a look at number 2. So number 2 is an integral of x e to the power of negative x squared. And we're given that u is equal to negative x squared, so now let's find du. So du is going to be negative 2x in that case, dx. And we could write it down here as well. So when you set up these equations, these are three things you kind of want to write down. So it's going to be u du is negative 2x dx, and you want to write down dx is equal to, it's going to be du because we're going to multiply by negative 2x. And these two things right here, u and dx, are going to be what you're going to plug into the equation. So those are some important things to know. So now we have the original equation here. Let's plug in for u and let's plug in dx. So we're going to have x e and then u because negative 2x squared is u, and dx is going to be du divided by negative 2x. And now we could see we have one variable here, x, and we wouldn't be able to work this antiderivative out with that x there. Not easily, exactly. But what we could do now is, you see on the denominator we have negative 2x. X and x are going to cancel out, so x and x are going to cancel out. And this negative 2, it's going to be negative 1/2, which is a constant, so we could bring it out. So we're going to have negative half integral of eu du. And now this is what we're left with. You can see it's a lot easier to find the antiderivative of this now, or integrate it. So if we integrate it, we're going to have eu, and we times negative 1/2, and we're left with this, and also plus c. And all we need to do now is just plug in for u. So u is going to be negative x squared. So our final answer is going to be negative 1/2 e to the negative x squared plus c. All right, so let's take a look at number 3. So number 3, we have x squared multiplied by square root of x cubed plus 1. So this is going to be a little bit like the same thing. We're going to use the same rules and whatever. So what's u? We're already given u. It's going to be x cubed plus 1. And that means du is going to be 3x squared. And dx, that means dx is going to be equal to du divided by 3x squared. And again, how we found out dx is that we divided by 3x squared on both sides, so that we get dx by itself. So now, since we have the important parts, all we need to do is plug everything in. So we're going to have integral of x squared, square root of u, and that's going to be du over 3x squared. And we can see we're left with this x squared, and in order to cancel out, we see we have this 3x squared in the denominator, and x squared are going to cancel out. And we're left with this 3, 1 over 3 rather. So now we could bring out that to the outside because it's a constant. So if we rewrite out, we're going to have 1 over 3 integral of square root of u du. Or rather, what we could do is rewrite that to be u to the 1/2 power and du. And now all we need to do is integrate. So we find the antiderivative of u to 1/2 power. It's going to be u 3/2 to 3/2 power because we added 1 to 1/2 divided by 3/2, which is going to be multiplied by 2 over 3. And it's going to be multiplied by 1 over 3 plus c. So now let's plug in u and let's simplify everything. So we're going to have 2 square root, or rather cube roots of x3 plus 1 squared. Because we have, since it's to the 3/2 power, it's going to be square rooted x3 plus 1, and that's the x3 plus 1 is going to be cubed. So that's going to be our numerator, and all that's going to be positive, and then on the bottom we're going to have 9 and plus c, and that is our final answer. And now let's take a look at number 4. Number 4 is something similar to what we did in the intro. So we have sine squared times cosine, sine squared theta times cosine theta, and we're given that u is equal to sine theta. So let's write it down here. So u is sine theta. That means du must be cosine theta dx, or d theta rather. That means that d theta is going to be equal to du over cosine theta. And now we know the important stuff, so let's start plugging it in. So we're going to have integral of, since it's sine squared and we plug in u for sine, we're going to have u squared now. And that's going to be multiplied by cosine theta and multiplied by d theta. And d theta is du over cosine theta. Du over cosine theta. And we can see we're left with the cosine. We don't want that there, so we also have a cosine denominator, coincidentally. So we could just cross these out, and we're going to be left with integral of u squared du. So you can see we're not left with any fractional constants on the outside, which is also pretty good. So now we just integrate this. So the antiderivative of u squared is going to be u to the third power over 3. And that's going to be plus c. And all we need to do now is just plug in for u. So u is sine theta. So our final answer is going to be sine cubed theta over 3 plus c. And that's our final answer. All right, so let's move on to number 5. So number 5, we can see we have a fraction here. But since we have u as u fourth negative 5, you're going to see why we shouldn't be scared of the fraction. So u is going to be u to the fourth power minus 5. That means du is going to be 4x cubed and dx. That means dx is going to equal du over 4x cubed. And you could kind of see a pattern here in which we're setting up the important stuff at the start, and then that's going to help us plug in stuff and find the integration of this question a lot easier. So if we rewrite it and plug in for u and dx, we're going to have integral of x cubed over u, and that's going to be multiplied by dx, which is going to be du over 4x cubed. And this is why you don't need to worry about the fact that we had an x cubed, because we have one down here, so we could just cross them out. And that means we have a 1 over 4, so we could bring it out to outside because it's a constant. We have 1 over 4 integration of, it would be 1 over u, but we could write it as u to negative 1 power. Or rather, we could actually leave it as 1 over u. You'll see why later. So 1 over u and du. And now all we need to do is just integrate 1 over u. So if you remember, ln of x is the derivative of that is going to be 1 over x times x prime. But in this case, the derivative of u is going to be 1. So that means the antiderivative of 1 over x would be ln of x. So our antiderivative of 1 over u is going to be ln of u and multiplied by 1 over 4 plus c. And now all we need to do is just plug in for u. So we're going to have 1 over 4 ln x to the fourth power minus 5 and plus c. And that is our final answer. And one thing I didn't note is that when you find the antiderivative and get ln, uh, ln can't be negative. It can never be negative. So we need to add some absolute value here, bars, to make sure that's true. So when you go from like 1 over x or 1 over whatever to ln of x, you want to add an absolute value here. But when you find the derivative of like ln of x, you don't need to put absolute value anymore. But let's go on to number 6. So now number 6 is going to be a pretty long equation. So we're given that, let me block this out here. So we're given that u is equal to 1 plus 1 over x. And now we need to find du. So du is going to be, derivative of 1 is going to be nothing, plus the derivative of 1 over x, which a good thing to know is that derivative of 1 over x is going to be negative 1 over x squared. That's because this is x to the negative 1 power, and then we just find the derivative of that. And that's going to be dx. So that means dx is going to be equal to du times negative x squared. And the reason why it's not in the denominator anymore is because uh, in order to remove x squared from the denominator here, we need to multiply by x squared on both sides and negative x squared actually, because we don't want dx to be negative. So now all we need to do again is just plug in everything. So we're given that 1 plus 1 over x is u, so we're going to have 1 over x squared, and then square root of u, and we're plugging for dx, which is going to be du times negative x squared. And we could kind of see we could cross out x squared, except this time it's like reversed. In the original function, it's going to be on denominator, and then when we plug in dx, it's going to be on numerator. But nonetheless, we could still cross it out. And we're left with 1 times radical u du multiplied by negative 1. So negative 1 is a constant, so we could bring that outside. We're going to have negative 1 integral of u to half power. We're going to rewrite it as that du. So now we just integrate it, find the antiderivative. So antiderivative of u to negative 1 half power is going to be u to the 3 half power divided by 3 half, which is going to be multiplied by 2 over 3. And that's going to be multiplied by negative 1 and plus c. And let's plug in u and let's add everything together, or rather simplify it. So our final answer is going to be negative 2 and 1 plus 1 over x. And that's going to be to the 3 half power. And denominator, we're just going to have 3 plus c over here. And we could put this to the square root and then the cube inside the square root. But you could also write as 3 half power, that's completely fine. But that would be your final answer here. Alright, so let's try these few questions here. So we're not given the u value here, so we have to figure it out. Now with u values is that you could pick any of the variables or anything in the function, but your main goal is to pick something that's going to help you answer it in the least amount of time. Because whatever you pick ultimately will give you the same answer, but the process may be more complex, and especially if you're time limited, it's not a very good idea if you pick a bad u value. But knowing what u value to pick is more of a case of practice rather than a formula or an understanding. But so let's take a look at number 26. So number 26, we have sine x times sine cosine x. So this is two trig functions here. So we want to remove since cosine of x is inside of sine x or sine, we can't remove the cosine of x, so we want to attempt to remove this sine of x over here. How could we do that? So we know that the derivative of cosine of x is negative sine x. That would help us remove the sine of x. So you could kind of visualize it there, so you could make the u value make sense, I guess. So let's say u to cosine of x. That means that du is going to be negative sine x dx. That means dx is going to be equal to du over negative sine of x. Now let's start plugging in stuff. So we're going to have integral of sine of x multiplied by sine, and then in the parentheses give me u because u substitutes in for cosine of x. And that's going to be multiplied by dx. Now we plug in for dx, which is going to be du over negative sine of x. And we can see we have a sine of x in denominator here, so we can just cross out sine and then sine. And we have a negative sign here, which would be negative 1 over 1. So we could bring that out the outside, which would be a constant. So we have negative 1 integral of sine u du. And you could kind of see that it's a lot easier to answer now the question itself. So, well, let's find the antiderivative of, or rather the integral of sine u. So we know the antiderivative of cosine x is going to be sine x, and we know a derivative of negative cosine of x is going to be sine of x, because derivative of cosine of x is going to be negative sine of x. So you just kind of flip the signs. So that means the antiderivative of sine of x, or sine u rather, is going to be negative cosine u. I have negative cosine u multiplied by -1, but since it's a negative times negative, we're going to have positive, and now it's going to be plus c. Now all we need to do is just plug in for c, or rather u. So we're going to have 1. This 1 can kind of go away. So we're going to have cosine and cosine x and plus c. And that is our final answer. All right, so let's take a look at number 27. So number 27, we have secant squared times tan to the third power. Find theta. So what do we know? We know that the derivative of tan theta is going to be secant squared theta. So if we plug in u for tan, we could get rid of the secant squared. So let's get the known information of this question. So let's say u is going to be tan theta, and du is going to be secant squared. That means secant squared theta d theta. So that means d theta is going to be equal to du over secant squared theta. And now we do the regular plugging in. So we're going to have integral of secant theta, secant squared theta, and since tan cubed, if we plug in for u, it's going to be u cubed, u to the third power, and then that's going to be d theta we plug in, which is going to be du over secant squared theta. And again, here we could cross out the secant squareds because they show up twice here. So we're actually just going to be left with u to the third power du and the integration of it. So now we just find the antiderivative of that, which is going to be u to the fourth power over 4 and plus c. And now we just plug in for c, which is going to be, or rather u, which is going to be 10. So we have tan to the fourth power theta over 4 plus c, and that is going to be our final answer. So let's take a look at number 28. So number 28 is going to be a little bit different here, but so let's find the u value first of integral of x and then times square root of x plus 2 dx. So let's set u to, we don't want to set u to x, so because we're going to have the square root of u plus 2 times u, and that's not really ideal to find the antiderivative of. So let's set u to the x plus 2, or u equal to x plus 2. Usually you want to set u to the more complicated stuff. That means that du is going to be equal to 1 dx, which is just dx. That means dx is going to be equal to du. So if we plug it in, we're going to have integral of x square root of du and then du. So we have an x value here, and you could see that we can't exactly get rid of it. What could we do to replace the x with something in terms of u? You could see that we have u is equal to x plus 2 over here. What if we solve for x? If we solve for x and we subtract 2 on both sides, we're going to have that x is equal to u minus 2. And now we're kind of working with some more information here, so we could plug in u minus 2 for x. So we would actually write this as integral of u minus 2 times square root of u du. And now we kind of have like two things going on here. We want to turn it into one, or rather something in which we could use a power rule or antiderivative, a rule in like the power rule to integrate it. So we could multiply this out. So if we multiply it out, we're going to have an integral u to the 3/2 power, because u to the 1 power multiplied by u to the 1/2 is 3/2, minus 2u to the 1/2 power du. And now you could see we have one variable here, so now we could find the antiderivative pretty easily. So antiderivative of u to the 3/2 power is going to be u to the 5/2 power multiplied by 2 over 5, or rather divided by 5 over 2, minus 2 u to the 3/2 power divided by 3/2, which is going to be multiplied by 2 over 3. So let's rewrite this. So it's going to be 2 over 5 u to the 5 over 2 power minus 4 over 3 u to the 3/2 power. And that's going to be plus c as well. So all we need to do now is just plug in for u, which is x plus 2. So we're going to have as our final answer 2 over 5 and x plus 2 to the 5 half power minus 4 over 3 x plus 2 to the 3 half power plus c. And of course, you could break x plus 2 5 over 2 into x plus 2 squared multiplied by square root of x plus 2. So you could break it up as well like that, but this would be, I'd say, the most simplified version right here for number 28. Now let's take a look at number 29. So we're kind of working with a lot of stuff here, so kind of move that around. So let's figure out u du and that's going to be dx. So what could we use u as? So we can kind of see this is the more complicated stuff and it's to the 5th power, so we kind of want to work with that here. So let's say u is equal to x squared plus 2 over x. So what would du be? Du would be 2x minus 2 over x squared. And that would be dx in parentheses right there. So that means dx is going to be equal to du over 2x minus 2 over x squared. Now let's start plugging in stuff. So if we rewrite the equation, we're going to have integral of x minus x 1 over x squared and multiplied by u over 5 because all of this is u. And that's going to be, we plug in dx, so it's going to be du over 2x minus 2 over x squared. So now that we've plugged in everything, we're left with this kind of thing going on here. Let me rewrite some of the exponents so it's a lot easier to divide everything and then get our final integral. So we're going to have integral of x minus x to a negative x squared, or negative x2 power, because it's in denominator of this. And you'll see why it's a lot easier to write it out this way. And that's going to be still multiplied by u to the 5th power. And that's going to be multiplied by du over 2x minus 2x to a negative 2 power. And you can see now that I've written out negative 2 powers and negative powers, we could start canceling out stuff without being confused. So let's cancel out this x. We have a 2x and then an x here. So if we cancel that out, we're just left with the constant of 1/2 or 2 on the denominator. And then we have a negative x to a negative 2 power. How could we cancel that out? We have a negative 2x to a negative 2 power here. So what we could do is just cancel out this negative and the negative, and the x to a negative 2 power. So we're on the denominator, we're left with 2 plus 2. So now that's a constant. That's going to be essentially 1 over 4. So we could bring that out to outside. Let's rewrite everything. So we're going to have 1 over 4 integral of u to the 5th power du. Now this is going to be a lot easier to find antiderivative of. So if we find the antiderivative, we're going to have 1 over 4 times u to the 6th power over 6. And that's going to be plus c as well. And now all we need to do is plug in for u. So let's actually delete this little part here so we could write the answer here. So we plug in for u, we're going to have u is going to be x squared plus 2 over x, as we originally decided. So it's going to be on numerator, x squared plus 2 over x, in parentheses to 6th power over 24, and plus c. And that's going to be our final answer for number 29. Alright, so I want you guys to try number 10, number 13, 14, and 15. So you can pause the video and try those out. Alright, so let's take a look at number 10. So number 10, we have integral of 5 minus 3x to the 10th power. And let's first write down the important stuff. So we have u, du, and dx. And so f minus 3x is mainly our thing that we're working with here. So we have to set that equal to u. a 5 minus 3x. That means that du is going to be have to equal to negative 3, and dx. That means dx is going to be equal to du over negative 3. And now let's start plugging in stuff. So we're going to have integral of u to the 10 power times dx, which is going to be du over negative 3. And negative 3 is a constant. It's going to be negative 1 over 3. So we could bring that to the outside. So we're going to have negative 1 over 3 integral of u to the 10th power du. Now we just find the antiderivative, which is going to be u to 11th power over 11 times 1 over 3 plus c. And if we plug in for u and simplify, we're going to have 5 minus 3x to the 11th power over 33 plus c as our final answer. And now let's take a look at number 13. So number 13, we have an integral of sine pi t over 3 dt. So this derivative, or this rather integral, is going to be in terms of t. So let's write down some important stuff here. So we've u, du, and dx. So what could we set u equal to? U, we want to set t equal to complicated stuff, which is going to be this pi t over 3 inside of here. Sine is not exactly complicated, and derivative of that is just going to be cosine. So u is going to be pi over 3, or I wrote u, but pi over 3 and times t. But t being a numerator is the same thing. And that means du is going to be equal to pi over 3, because the t goes away. And that's dx for this. I believe, oh no, for this is dt actually. So we're not finding any dx here. So this can be dt. So that means dt is equal to du. And we multiply by 3 to take it to the other side. So it's going to be du over pi times 3. And now we just start doing our plugging in stuff. So we're going to have sine u is going to be multiplied by dt, but dt is going to be equal to du over pi times 3, which is just essentially 3 over pi. So 3 over pi is a constant because pi is a constant number. It's one number. So we could bring 3 pi to the outside, and we're going to have integral of sine u du. And now we just find the antiderivative. So antiderivative of sine is going to be negative cosine. I mean negative cosine u plus c, and then multiplied over here by 3 over pi. So let's simplify this a little further and plug in for u. So we're going to have negative 3 cosine pi over 3t, and then denominator is just going to be pi and then plus c. And that's our final antiderivative. And now let's take a look at number 14. So number 14, we have integral of secant squared to theta, d theta. So let's see what u, du, and dt can equal. So we can set u equal to rather d theta because it's the more complicated thing here. So if we set u equal to d theta, that means that du is going to be equal to just 2 d theta. And that means dt, or rather d theta, actually, I don't know why I wrote dt. D theta is going to be equal to du over 2. Now we just do our plugging in, so we're going to have integral of secant squared u is going to be equal to, uh, or is going to be multiplied by du over 2. And since we know that, well, there's a 2 in the denominator, we know that's 1/2. 1/2 is a constant, so let's bring that to the outside. So we're going to have 1/2 integral of secant squared u du. So how can we find the antiderivative of du? If we think back to trig derivatives, what's the derivative of tan x? Or even tan u? Derivative of tan x, if you remember, that's secant x. So that means the antiderivative of secant x is going to be tan x. So that's what we just do here. So if we find the antiderivative, it's going to be 1/2 multiplied by tan u plus c. And if we plug in for u, we're going to have 1/2 times tan 2 theta plus c. It's kind of interrupted whatever's going on here, but all right, that is going to be our final answer for number 14. And now let's take a look at number 15. So number 15 is sort of like what we haven't seen before, but let me get this situated here. So number 15 is going to be dx over 4x plus 7. So if you rewrite it, we're going to have integral of 1 over 4x plus 7 and dx. So let's write down our important stuff like always. So we have u is equal to, we could only set it equal to 4x plus 7 here, so it's going to be equal to 4x plus 7, and du is going to be equal to 4 dx. That means dx is going to be equal to du over 4. And now let's start plugging in stuff. So we're going to have the integral of 1 over u, and the reason, you'll see a reason why I'm not putting u to -1 power. And we're going to add in, or plug in dx, which is going to be du over 4. And since 4 in the denominator is going to be a constant, which is 1 over 4, we could bring it to the outside. So we're going to have 1 over 4 integral of 1 over u du. And what's the antiderivative of 1 over something, or 1 over u? That's going to be ln of u. So the antiderivative of this is going to be 1 over 4 times ln u and plus c. So now all we need to do is just plug in for u. So if we plug in for u, we're going to have a 1 over 4 ln 4x plus 7 plus c, and that's our final derivative for number 15. Alright, so I want you guys to try number 50, 53, and 54. So you could pause the video and try those out. Alright, so let's take a look at number 50. So number 50, we have x over 1 plus x to the fourth power. So this is, the way we're going to answer is not going to be traditional like to the other questions. But let's say we had u is going to be equal to 1 plus x4. Then that means we're going to have 4x to the third power. And we have x on the top, so we're like net going to be left with 4x to second power when we plug in u, in which we don't want to be left with that. So what can we put in that case? What can we put as u in the case that the derivative is going to help us cancel out x and leave us with only one variable being u? If you think about it, it would be u squared, right? So what we would do here, we would set u as equal to x squared. So which means du is going to be equal to 2x dx, and that means dx is going to be equal to du over 2x. And now let's start plugging in stuff. So if we plug it in, we have integral of x over 1 plus u squared, because u is going to be x squared. X squared squared is going to be x to the fourth power. And times dx, which is going to be du over 2x. And you can see now we could cross out the x's. We could delete them forever. So we cross out the x's and we have 1/2 over here. So we just bring that outside. So if we rewrite it, we're going to have integral of 1/2 on the outside. We're going to have integral of 1 over 1 plus u squared and du. So this involves some important rules that are important to know, especially arctan. So what is the antiderivative of this? The antiderivative of this would be arctan, because arctan is equal to, essentially in terms of a function of x, it would be equal to 1 over 1 plus x squared. And you could see we kind of have that in u. Now these two are also important, arc sine and arc cosine. So arc sine is going to be equal to 1 over square root of 1 minus x squared. And arc cosine is going to be equal to 1 over square root of 1 plus x squared. And arc is basically the inverse. So it's arc cosine would essentially be cosine negative 1x if you were to plug it into a calculator. But this is kind of important to know, especially with u substitution and integration further on. So we're left with 1 over 1 plus u squared over here. If we integrate it, we're going to have 1/2 times arc tan u, and that would be plus c. Now all we need to do is just plug in for u, so we're going to have arc tan, and we plug in for u, which is x squared, so we're going to have arc tan x squared over 2 plus c, and that's going to be our final answer. And now let's take a look at number 53. So number 53, we could set the u, we want to set the u to the more complicated stuff, which is going to be 2x plus 5 to 8th power. So for our u is going to be 2x plus 5. And let me block that away. So that means du is going to be equal to 2 dx, which means that dx is going to be equal to du over 2. And now let's rewrite everything. So we're going to have integral x u to the 8th power and dx, which is going to be du over 2. You could kind of see here we haven't been able to successfully remove the x value, but what could we also do like we've done before? We know we have this u is equal to 2x plus 5. So let's just find this and basically get x by itself. So we would have to subtract 5 on both sides and divide by 2. So we would have u minus 5 over 2 is equal to x. Now all we need to do is just plug in that for x. So we're going to have, if we rewrite it and plug in that x, we're going to have u minus, or rather negative 5 squared u and times u to the 8th power du. And we know negative 5 over 2 is a constant, so we could bring that outside. So we're going to negative 5 over 2 integral, and we're going to be left with u times u to the power of 8. So it's basically u to the first power times u to the 8th power, which is going to be u to the 9th power du. And now we could just easily find the antiderivative or integrate it. So we're going to have negative 5 over 2 multiplied by u to 10 power over 10 plus c. And now let's simplify everything and plug in for u, and with u being 2x plus 5. So if we simplify and plug in for u, we're going to have 5, 2x plus 5 to the 10th power, and then denominator, we're going to have a 20. You could also simplify this to 1 over 4 and plus c. So that is going to be our final or rather integration of 53. Alright, so now let's do number 54. So number 54, let's find the u du, and this is going to be dx. So we could see that if we set u equal to x3, we would have 3x squared for du, but it wouldn't necessarily cancel out x squared, so we'd still have the x squared there. And x squared plus 1 is kind of the more complicated stuff, so let's set that equal to u. So we have x squared plus 1 as u, and du is going to be 2x. And that means dx is going to be du over 2x. And you can kind of see how it's going to work out in the end here. So if we plug everything in, it's going to be integral of x3, or x cubed rather, times the square root of u times dx, which is going to be du over 2x. And we have an x cubed here and a 2x, so we could kind of cross out the x and decrease this x3 to x2. And we could also take the 2 to the outside, which would be a constant, so we would have 1/2 integral of x squared times the square root of u du. So what can we do to remove this x squared? Because we don't want this here, we just want u. We know we also have this here, u is equal to x squared plus 1. So all we need to do is just get x squared by itself. So we just subtract subtract 1 on both sides. So we're going to have x squared is equal to u minus 1. So now that we just plug in x squared u minus 1 into here, So we're gonna have 1/2 integral of u minus 1 times the square root of u. You could kind of see this is similar like a question we did previously, but now all we need to do is just multiply all of this out and then we can integrate it. So we multiply it out, we're going to have 1/2 integral of u to the 3/2 power minus u to the 1/2 power du. Because we have a square root of u, which is u to 1/2 power multiplied by u to 1 power minus, and multiplied by -1. And now we just find the antiderivative, so it's going to be 1/2 in parentheses u to the 5/2 power divided by 5/2, which would be multiplied by 2/5 minus u to the 3/2 power divided by 3/2, which is going to be multiplied by 2/3 and plus c. And now finally all we need to do is just simplify everything, multiply it out, and plug in for u, which is going to be x squared plus 1. So if we do that, we're going to have 2x squared plus 1 to the 5/2 power over 10, because I'm also multiplying now with the 1/2. And we're going to have minus 2 to the x squared plus 1 power, or x squared plus 1 to the 3/2 power over 6 and plus c. And that is also our final answer now. And you could see even though we had a u value that didn't directly cross out x cubed, we were able to kind of cross it out by using the known information we have to create new information so that we could further assist ourselves in the question. So that's the integration of number 54. Alright, so that was basically for u substitution rule. So you could kind of see how we're using u, du, and then dx to help us answer the question, which I think an important part is whenever you start a question, write down your known information, which is going to be your u, du, and dx. And you could also find x in terms of u, but this will ultimately help you plug in stuff for the equation and use u substitution in order to get something that's going to be easier to integrate. Essentially, that's the whole purpose of u substitution. Just making everything easier to integrate. So yeah, it's basically it.